Hello everyone and welcome back. This is Bijan Ushia. In this chapter, we are going to discuss IPv4 and IPv6 addressing, their structures, their prefix and prefix length, or net ID and host ID, and also different classes for IPv4, in addition to different types of IP addresses that we have. Hope you enjoy it. Thank you very much.
All devices in IP networks need IP addresses to communicate. There are two versions of IP addresses. They are IP version 4 and IP version 6. Each IP address is made of two parts. They are network portion that can also be called prefix or net ID, and the other portion is host portion, which can also be referred to as interface ID or host ID. Net ID is the same for all IP addresses in a network. Host ID is unique per device in the same network. Subnet mask or prefix length is used to distinguish net ID from host ID. Subnet mask is made of a block of binary ones followed by a block of binary zeros. Binary ones in the subnet mask point to the net ID, and binary zeros in the subnet mask point to the host ID portion of the IP address. There are different classes of IPv4 addresses. They are Class A, Class B, Class C, and Class D. They are going to be distinguished from each other based on their first octet range and the default subnet mask that they have. In a Class A IPv4 address, the first 8 bits are part of the net ID. Therefore, the most number of the hosts exist in any Class A network address. In a Class B IPv4 address, the first 16 bits are part of the net ID. In a Class C IPv4 address, the first 24 bits are part of the net ID. Therefore, the least number of the hosts exist in any one Class C network address because the host ID portion is only 8 bits, the last octet. Class D is set aside for multicast. Class A, Class B, Class C, and Class D are also referred to as classful IPv4 addresses. IPv4 is a 32-bit binary number that can be represented in decimal dotted format. Same is true for subnet mask. In here, a 32-bit IPv4 address is shown. In order to convert it to decimal dotted format, we are going to divide that 32-bit into 4 groups. Each group is going to be referred to as an octet. We are going to place a dot between the octets to separate them from each other. Then, the binary value of each octet is converted to its decimal equivalent in order to obtain the decimal dotted format. Same is true for subnet mask. If you place all binary zeros in the host ID portion of an IP address, then you have a network address, a range of addresses. If you have all binary zeros in the host ID portion except the least significant bit, then you have the first IP address of the range, the first host ID, the first host address. If you place all binary ones in the host ID portion except the least significant bit, you obtain the last host address or last usable IPv4 address of the range. If you place all binary ones in the host ID portion, you obtain the broadcast IPv4 address of that network address. When you have all binary zeros in the host ID portion and when you have all binary ones in the host ID portion, you cannot assign them to any one device. IPv4 addresses could be private, special, and registered IP addresses. Private IPv4 addresses are following: any IPv4 address starting with 10, any IPv4 address starting with 172.16 through 172.31, and any IPv4 address with the first 2 octets of 192.168. Those are considered private IPv4 addresses and you cannot go to internet with them. But some of you may see the same type of private IPv4 addresses on your home router and you can access internet. The reason is that you are hiding behind your service provider's NAT server. Special IPv4 addresses are following: 0.0.0.0.0 with the subnet mask of 0.0.0.0.0. It can be used for creating a default route. It cannot be assigned to any one device. Another special IPv4 address is the one that is starting with 127, specifically 127.0.0.1, which is called loopback IPv4 address. It is being used to test your TCP/IP configurations. Any IPv4 address that has the first two octets of 169.254 is considered API-IPA. Sometimes you configure your devices to receive IPv4 address from a DHCP server, but DHCP server is down. In that case, your host is going to act as its own DHCP server and it's going to assign itself an IPv4 address from the range of 169.254. With that type of IPv4 address, you can communicate with other hosts that have the same type of IPv4 address, and as long as they are in your network, because with API-IPA IPv4 addresses you cannot exit from your network. IP addresses that have the first octet range of 1 through 223, except the ones that I mentioned under private and special IPv4 addresses, are considered to be public IPv4 addresses. If you pay for them and obtain them from the internet authorities, you can access the internet with them. IPv4 can be configured as unicast, broadcast, and multicast. Multicast IPv4 addresses have the first octet range of 224 through 239. IPv6 is a 128-bit binary number that is represented by 32 hexadecimal digits grouped in 8 hexadecimal separated by colons. IPv6 addresses can have either of the following formats: preferred format, no leading zeros format, and compressed format. Preferred format is when you write down all 32 hexadecimal digits. No leading zeros format is when you eliminate the zeros to the most significant part of the number in each hexadecimal. Compressed format is when you replace contiguous hexadecimal with value of 0 in them with a double colon. Double colon cannot be repeated more than once. There are unicast, multicast, and anycast IPv6 addresses. There is no broadcast IPv6 address. Unicast is for one-to-one communication, multicast is one to a group. Anycast means the same unicast IPv6 address being assigned to multiple devices. Packets sent to anycast address is going to be routed to the nearest device. There are different unicast IPv6 addresses based on the value that they have in their first hexadecimal. Public unicast IPv6 addresses are the same as registered IPv4 addresses. They have the first hexadecimal range of 2000 through 3FFF. Private unicast IPv6 addresses are the same as API-IPA IPv4 addresses. They are also referred to as link local addresses. They have the first hexadecimal range of FE80 through FEBF. There are also some special unicast IPv6 addresses. For example, for loopback, which is the same as 127.0.0.1 in IPv4, we use an IPv6 address that is :1/128. Private unicast IPv6 addresses are the same as RFC 1918 IPv4 addresses, the one that started with 10 with 172.16 through 172.31 and the one that started with 192.168. The first hexadecimal range of private unicast IPv6 addresses is FC00 through FDFF. There are different multicast IPv6 addresses. They are assigned multicast and solicited node multicast. Assigned multicast could be all nodes multicast group and all routers multicast group. Anytime that you configure a device with an IPv6 address, it will automatically join all nodes multicast group. Whenever you configure your router with IPv6 unicast-routing command, that router will join all routers multicast group. Solicited node multicast is a special IPv6 address mapped to the MAC address of a destination device and used by ICMP version 6 to resolve IPv6 address to MAC address.
Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.